Okay, so hello everyone. Thank you for joining this webinar. So the topic for today is how to implement demand forecasting best practices in simple words and steps. Let me move to the next slide. So your speaker for today, actually, we are two people. So there's Nicolas Vandeput that you can see apparently with his camera. So he's a consultant and the author of several books. In particular, he's also the author of Data Science for Supply Chain Forecast. So he will give us an overview about the demand forecasting framework. I'm Stephane Leclercq. I'm the CEO of SKU Science, and I will show you some demo after the presentation. So we have the agenda for today. So first, Nicolas will go with the 4-dimension demand forecasting framework. And then, as I said, I will go with a quick demo to explain how we support this framework. And we'll have a Q&A session at the end if you have any question. And as I said earlier, Thomas is also active remotely. So if you want to post any question while we're talking, feel free to do so. So now I'm going to give the hand to Nicolas. Let me try to do this. Do you have the right, Nicolas?
I am. Yeah, I think you see my screen now, right?
Yeah, sure.
Perfect, great. So, hello everyone. So, the objective of the webinar today is really to share with you some of the best practices I noted down over the last years in terms of demand forecasting. The objective is really to make them as simple and as actionable as possible so that you, within an hour, you can go back to your job and really know, okay, on what do I need to focus and what can I do to improve demand forecasting. As I speak, do not hesitate to type question either in the conversation or in the Q&R. And then after the presentation, we'll have a discussion and chat to go through your questions. So feel free to ask any question. I'm very happy to discuss. So let me start by the beginning. When I teach demand forecasting at university, when I train practitioners about demand forecasting, the first question I always ask the audience is, why do we need to forecast? Why do we forecast demand? People would reply, we want to improve supply, we want to order the right goods, we want to produce the right material, we want to feed demand, we don't want to have overstock, and so on and so on. So basically, it's either improving top line or bottom line, right? There is one answer that no one ever gave me, ever, is to say we forecast demand just for the sake of it because we love numbers. No one is doing that. Actually, when you think about a supply chain, it's some kind of a living organism that needs to take hundreds, thousands of decisions every week. And when you need to make a good decision, right, you need to have the right information. So why do we forecast demand? We forecast demand to give the supply chain the right pieces of information so that the supply chain can make the right decision. Okay? So taking this into account, I came up with a 4-dimension framework that I like to review when I start a project with a company. I like to go through these dimensions one by one to set up the right demand forecasting process. And really at the core of this lies the fact that you forecast demand to take action. Okay, so let's go through these dimensions one by one, and you will understand why this concept of decision is so important. So when you do a forecast, when you forecast demand, the first choice you have to make is, okay, what is the right granularity and what's the right temporality? So in terms of granularity, you can make a forecast per product, you can make a forecast per product family, per brand, you can even do it in terms of value, in terms of weight, and so on. In terms of geography, you can do a forecast per country, per region, per store, per client, and so on and so on. What we see, and you see it here in the slide, you can basically zoom in and out. So if you have a forecast per store, you can just aggregate it to the global level. The same way as if you have a forecast per product, you can go up to the total level that could be either in product or in value. Now you also need to assess what's the right temporality that you want in your forecast. Do you want to do a forecast per day, per week, per month? But do you need a forecast for the next few weeks, for the next few months, for the next quarter, for the next years, right? So we see that we need to take a few decisions on what exactly we need to forecast. What is very important is that it doesn't come for free. You cannot possibly do a forecast for the next 5 years per product, per store, per day. That would be way too complex, right? You could possibly make a forecast for the next few weeks, per day, per store, per product. But if you look over the next years, you might want to do a forecast maybe per quarter, maybe per brand or per product segments, and at a regional or a country level, right? So we see that there is some kind of a trade-off to do between complexity and the accuracy you expect, right? Somehow I could just say that the temporal horizon as well as the granularity, they will cost you accuracy. So you have to make a choice, right? You cannot basically get as much granularity as you want. Now you might ask yourself the question, okay, Nicolas, that's a nice set of choice that we need to do in our supply chain, but how do we know? How do we know what we need to do? Well, again, going one step backward, at the core of this, again, lies the question that you want to take action. Maybe you want to order some goods from an overseas supplier. Maybe the action you want to take is to supply some local stores, right? So based on these actions, you're gonna decide what granularity you need. Let me show you a few examples. Then again, if you have any question, feel free to type it in the conversation box. I'm going to read that after the presentation. Feel free to type Q&R. Again, we will go through this. We will discuss that with you. And if we do not have the opportunity to answer your question now, we can come back to you by mail after the session. So, okay, let me show you a few different examples of action that the supply chain needs to take. So on the right hand, you see that a typical short-term action would be, how much goods do I need to ship? How much product should I produce, right? These kind of question, it's something that typically logistic manager needs to know. And they will like to have a forecast that would be typically by SKU, by store, by weeks, right? If your job is to ship your goods from your central warehouse to the local stores, you need to have a forecast per store, per week, and per product, right? Skipping the midterm and going to long term, you could also need a long-term forecast to take decisions like, should I open a new plant? Should I close this store? Should I launch a new brand? How much should I produce for the next year's season, and so on? If you want to do these kind of forecasts, you do not need to have a forecast per product per week. Maybe if you have a forecast at the brand level and per quarter, it might be enough. And if you do it at a global level, it might also be enough, right? So we see that at short term and at long term, you don't exactly need the same amount of granularity, and this is fine. Okay, so another question that I often ask to people after this slide is, do you absolutely need in a supply chain some kind of fully reconciled forecast between the most short-term horizon and the longest-term horizon based on decision? Well, in some case, yes, you might want to really align the forecast on the most granular level, which is per week, per day, per store, and per SKU, with the most long-term forecast, which might be per quarter. In some other case, in some other company, you don't absolutely need to do that. You might just keep two different forecasts that are just closely related, close to each other, and based on the same kind of assumption. Again, that's a very interesting debate that I often have with practitioners when I do this kind of training. I'm very happy to rediscuss this with you later. Okay, so now that we've discussed the granularity and the temporality of your demand forecasting process, we should discuss the metric. So when you try to assess if a forecast is good or bad, you basically have two things that you need to take into account. You need to be sure that your forecast is not biased. It means that you do not tend to over forecast or under forecast over the long term, right? In average, you're just at the right level, and you want to be sure that you're accurate. It means that the amplitude of the error is rather low. It can be a bit confusing for people, but actually you could have a forecast that's accurate and biased, or that is not biased, but it's not accurate neither, right? Before we move further, I really want to stress once again that the metric that you use to assess your forecast quality should really be aligned with your objective. again, I will never tell you, well, we want to have metrics just for the beauty of math or just for the pleasure of doing administration or budgeting, whatever. No, we want to help you to take the right decision. And this is why we need to choose the metric that will support the decision you need to take. Okay, let's move on and rediscuss this concept of bias and accuracy. So maybe some of you here would be thinking, how is it possible that you could be at the same time accurate and biased, or not accurate and not biased? Well, let me show you an example. You see here on the right that we have a demand, right? So you have some sales, let's say every month, and you have two forecasts. One is the orange one, which is like not accurate, like it fluctuates a lot, right? But overall, it has the right average. On the other hand, you have the gray one, which is always or nearly always a bit too low, but it's quite close to the blue signal. So what we see is that we have a first forecast that is not accurate, but not biased. And we have a second one that is not biased, but that's not so accurate. And we see that basically, some of you would say, I prefer the gray one, and some other would say, I prefer the orange one. Personally, I have no preference. I just want to warn you that depending on the metric you use and which metric is the most important to you, you might prefer one forecast or the other. Okay, so it's very important when we set up a forecasting process that we understand that based on the decision we want to take, we really need to understand what are the best metric. Okay. By the way, here, if I move back to the next slide, we have the gray forecast would be accurate but biased, whereas the orange one would be not accurate and unbiased. So overall, in supply chain, we see three main kind of KPI. We have the mean absolute error, we have the MAPI, and we have the root mean square error. Usually when I do this training with student and practitioner, I take at least an hour to go through every single metric to show them the pro and con of them. What's really important to understand here is that there is no perfect metric. So you might need to do some trade-off in between choosing one or the other. Now, there is something that's very important for you to know, and I think that that should be one of the main takeover, and I know it surprised many people, so be ready for it. MAPI is actually the worst KPI. So if today in your supply chain you're tracking MAPI to know if your forecast is good or bad, I would really advise you should stop to do that. MAPI is really the worst. How comes it's the worst? Because it's heavily biased. That means that if I want to do a really good forecast that achieve a really good MAPI, I can just produce a forecast that's really, really too low or extremely conservative, and I would achieve a really good MAPI, right? All the academics all agree on the fact that MAPI shouldn't be used, and I've been advocating it for years that people in supply chain should really move out of MAPI. What do we do then? Well, something that's nice to do is to look at the mean absolute error and the bias at the same time. So you try to be sure that your forecast is at the same time accurate and at the same time not biased. I would say that today, for many supply chain, this is considered as the best practice, using both mean absolute error and bias, but we can push it further. There is something, and we're going to talk about it again in a few slides, because I think it's extremely important for you, and it will create, I think, a lot of value for you to do that. Basically, in a supply chain, not every single product is equally important and valuable, right? You have some products that are worth a lot, very important product, very profitable, I don't know, strategic product. And on the other hand, you have some product that, well, you do not care so much about them because it doesn't cost so much or it's not profitable. With the weighted mean absolute error, you want to give more importance to the product that are more profitable or more valuable, so that when you compute the forecast error, those products get more importance, right? So by using this kind of metric, you would make sure that the metric is helping you as a planner to focus on the most important item. Okay, we will come back to this in a few slides. So that's it for the metric net. Let me discuss the process with you. So usual demand forecasting, wait, before I continue, again, if you have any question, feel free to note them in the conversation box or in the Q&A. I will, at the end of the session, go through it with you and answer as many questions as I can. So really, do not hesitate, feel free to type a question, we'll discuss that together. So let me discuss about the process now. So usually demand forecasting process in a company will look like this one. You have some initial forecast baseline. It means that the forecast engine populated a baseline forecast, right? Then you have the demand planners that are gonna work on it. And they're gonna add some information. They're gonna, I don't know, tweak products up, down, and so on. And they have some ideas because they got information from client and so on. Next to this, you usually have the sales team, maybe the finance team, the marketing team, and a final consensus meeting. What we see is that often, and here I just show one example, but it could be, I mean, totally different, of course. Often people have some kind of interest to lower the forecast so that they can say that they beat the forecast, or they want to have a too high forecast so that they make sure that you get enough supply and so on. So if you're the manager of such a process, you really want to make sure of two things. First thing, you want to be sure that the people that update the forecast, that change the forecast, create value. They add accuracy to your process, right? You don't want people to tweak the forecast and destroy accuracy, right? The second thing you want to be sure of is that people don't spend too much time on the forecast. We would agree that if someone edits the forecast for the first few hours, he's going to put, or she's going to put the best idea and the most relevant information in the forecast. But after maybe a few days, there is basically no more information to add in the forecast, and you would want this team member to move on to other activity. So basically, if I would summarize this, you want your team, you want the team to have some efficacy, but also to have some efficiency. So how do we make sure that people do the right thing and that people don't spend too much time on it? Well, there is a framework called forecast value added. And if you're interested, it was proposed in 2010 by Michael Gilliland in his book, which is the reference is here under the slide. A very nice book. So the idea is the following. When we're going to track the accuracy of a forecast, instead of just tracking the final accuracy of the final forecast, we're going to track the accuracy of each step. And then we'll be able to say this specific team created or removed value of the forecast. So for example, here, we start with a benchmark and say, okay, the benchmark achieved a mean absolute error of 52%. Then we have the baseline forecast. Typically, that would be the forecast engine. And this created value because it reduced the mean absolute error from 52% to 45%. So you say, great, we have a good forecasting tool that created some accuracy, it delivered value, right? Then you have the demand planners, they spend 72 hours and they definitely, again, reduced the forecast error. So they did a great job. But what you see then, thanks to this framework, is that the last team, the sales team and the consensus meeting couldn't improve the forecast. So basically they spent time editing the forecast, but they couldn't deliver value into it, right? So how do we do? How do we go to this team and we explain them how to edit the forecast? I have two advice for you. First one, I would simply ask this team, please do not spend as much time on this thing and just focus on the few items that you think are the most relevant, right? Because we hope that for the few items that they think are the most relevant, they will really create value. Second thing we need to ask them, usually if people know something that the model is not aware of, they should feel free to update the forecast. Let me give you an example. If you're aware that there is a price change in one of your products next month, you should feel entitled to go and change the forecast up or down because you possess an information, the price change, that your tool doesn't have. On the other hand, if your forecast engine knows about pricing, you also know about pricing, you shouldn't feel like, okay, I need to touch the forecast because I know something the tool doesn't. No, the tool is already aware of it, so you shouldn't touch it, okay? Let me then go to my last slide for today, the last concept. That's the one I already introduced in a few earlier slides. It's the concept of weighted metric. So the idea here, and I think it's extremely important for supply chain, is that not every single product, not every single SKU is equally important, okay? Let's go through an example. If I'm a forecaster at a company that's selling hammers and nails, and I have this setup here with a specific forecast for both the hammer and the nail, if I just blindly compute the forecast error, I would get this number here. And if me, as a planner, I wanted to improve this forecast, I would definitely work to improve the nail, right? The nails, because it's so numerous, this is what's driving the error. But when you think about it, the value of a nail is extremely low, right? We simply nearly do not care about nails. What we care about are the hammers, which are much more valuable, right? So if I would weight here the error based on the value of the hammer and the nail, maybe let's say a hammer is worth €5, whereas a nail is only worth 1 cent. We see that basically here what's driving the error is the hammer. So me as a planner, I will not care about the nail anymore. I'm gonna take care of the hammers, right? And us as the supply chain as a whole, we want the planners to spend time on the hammer, but not to spend time on the nail, right? So if we want to achieve this, we need to use what's called this weighted mean absolute error, okay? This concept also comes from the second edition of my book, which is going to be out, and I think I can say it now, on I think the 5th of April 2021. It should be available as of then, and they are really go in detail on the concept of weighted metric. I think that's it for me. So I'm just quickly going to check if there are any question conversation, and in the meantime, I'm going to give the presentation role to Stephane, who can prepare his presentation. Let me do that. Yep, voilà, Stephane, you have the ability to present. Let me check the conversation and the question. So it seems that there are no question yet. Again, feel free to ask question. I'm very happy to take the time with you to answer them. I'm very happy to debate some topics. So if you have any question, feel free to type them. Stephane, the floor is yours.
Thanks. Can you see my screen now?
Yes, we do.
I assume you can. Okay, let me remove the video. Okay, put it here. Okay, so thank you, Nicolas, for the presentation. So I'm going to try to explain and map all these concepts to the SKU Science platform. Before I go into those details, I'd like to show you, so I'm in the platform right now, that there is a special demo mode that you can get access to. So once you create your free account, you can access, a pre-populated account with 10 forecasts, and you can actually play with those forecasts similarly to what I'm going to show you with the demo. Okay. So I'm switching back to this to my account. Okay, moving back to the regular standard database. So in this presentation, actually, you can see that I have 100 forecasts in this account. And as Nicolas explained, I will start by highlighting how we handle the granularity of the forecast. Okay, so if I click on one forecast, this one, you can see that the name of the forecast here is composed of basically two information. First, this is a part number and the customer level. So this means that the lowest granularity that we have set up in the tool for this particular account is at the part number customer level. So if I go back to this information, for example, you can see that I have the same part number here, okay, with different customer, okay. So this is our finest level of forecast, and we can combine them as any, with any type of possibility. This doesn't prevent us to actually get the forecast once we have this forecast at another level, which is the part number or the customer level. And I will show you this information. But if I go back to the forecast information, so you'll see the field that we have actually loaded for this particular one. So we have the part number, we have the customer information. We have also some information regarding the sales channel and also some product family. So this part number belongs to this product family. Okay. So if I want to see the forecast that has been computed at the part number customer level, I just need to select in this aggregation table the level I'd like to see. For example, here I'm asking to see all the forecasts at the part number level. So this is actually a sum of all the other forecasts for this particular part number. And you see, if I display this information, I can see the information for this part number. I can similarly ask it to see it at the customer level. You just need to select customer or any other field, and automatically the tool will compute this information. Okay. Going back to the part number, I will show you that you can change the forecast at any level. So here, you know, I have the possibility to change this data for March and replace it with, let's say, 700,000. And automatically, the information is downstream to the forecast, which are located at the lower level. So if I go back to this lower level forecast, you can see here in March that I have a new data that is overwriting the forecast that has been computed by the tool. Okay, so this information here is the data that has been computed by the tool based on the historical data, the demand in blue, and the red line is the forecast, and the blue dotted line is actually how the forecast model applies to the historical data. I can also change this information at this level. Okay, let's say I want to change it here. And if I go back to a lower level, which is the part number, you can see that this information has been actually highlighted here. So this is how you can play with granularity. And as you see, we have different level, and you just need to define the lowest level for your particular business, and then it's very easy to work at different levels. That's it for the granularity part. So I will move to the temporality, which is the second part. So if you look at my forecast, this one we've set up, you know, in the database or time bucket to it's a monthly bucket. Okay, so you see I'm predicting the data every month. Okay, but this doesn't prevent us to see a global organization. We can go create some particular reports where, for example, we want to see the forecast at the quarter level. So I'm just showing an example here. So you see I have all the forecast. I have added some information, and you can see all the quarter. And it's very easy to change the type of format that you'd like to see. You know, you just need to move and select the proper format in this section. Okay. So that's it for the granularity, also temporality. Sorry. So now I will move to the metrics and the KPIs. So in order to get KPIs, you need to get many forecasts or several forecasts because you can compare actually your forecast with the real data. So here, for example, you see that the latest demand data that we have loaded is the one from December, okay, order before. And so basically, this means we are in January, and the latest forecast we have is the one from January. But let's assume we are moving to a next cycle, okay? We load the data from January. And when we do this, we will update the forecast, create a new forecast based on this latest data. And automatically, the platform will archive this existing forecast that will become the January forecast. So if you look here, you can see that I have several forecasts that has been actually archived based on the various activities that we had. And for example, if I select to display the one from July, you can compare graphically the real data in blue with the forecast that we created in July. Okay, the dots in yellow, and still we have the current one, and you see how close you are. So this is the graphical part, but not only we provide you a way to see this graphically at this level, you also have some tables that are automatically computed based on all this archive. And so I will explain now the concept of these parameters that basically, as you see, it changes the content of the table, and it's all done automatically. This is very powerful, but as Nicolas explained, when you create your forecast, you create it for your particular supply chain, and in particular, you have a specific lead time. So let's say you have a lead time of 2 months, okay? And you actually, so if you need to predict the data from December, and here this is the real data that I'm displaying, you need actually, if you want to be efficient, you need to be able to be as close as possible to this data 2 months in advance, which means in October. So this means that you need to analyze this data, the real demand data, 2 months for the forecast that is related to this particular lead time. And this is what I'm selecting here. And you can see that when I do this, we still have the same demand data. However, we compute, and the tool compute the data that has been actually created by the platform, and see how close you were for this particular period. So here, you know, I mean, the baseline, the SKU Science baseline was 10,000 above this amount, okay? But you can see automatically that it's computed. So you see the bias version, so it's the sign error, and you can see all the percentage for the bias, for the error, as well as the forecast accuracy, which is the complementary information up to 100%. So you can access this information for every forecast, but not only you can see this at the lowest level, you can also see it at the aggregation level. Okay. Before jumping to the aggregation level, I want to show you that you can see this information also graphically. So, okay, so I'm displaying this, and you have this threshold that actually you can set up by yourself based on how close, which type of color coding you want to use in regard to specific forecast accuracy or error, and you can see if you are in the right zone or not. Okay, so that's a way to do it. So now I'm going to keep moving to the metrics, but at the aggregated level. So as I showed you before, you can also, for example, access this information at the part number level. And here we have the KPI tab that displays the same information for this particular part number. So if I select this table, I can see the exact same table, but computed for this part number. This is done automatically by the tool. You don't have to do anything else. And not only you see it in units, which is important, as Nicolas mentioned, but we also provide the possibility, for example, to see this weighted error. So let's say you want to see it revenue based. So you select price, and automatically you can see that for this part number, okay, you see what was the error, but organized, you know, in a financial manner. And if I unselect this, for example, if I want to see the data from December, I can see that the one that was really the main error for my business was this particular part number. And this is really the one where I need to spend some effort to be better for the next cycle. Okay, so this is really the flexibility that the platform provides you in order to play with these different metrics and KPI, and you have the ability to analyze them, you know, at any level, from the lowest up to a much bigger level. Okay, so that's the metrics part. So now I will show you about the process, and you can keep track about the process. I know I've been quick on the table description, but I will spend more time now to explain this information. So as a user, I mean, you can modify and overwrite some data that the tool has computed for you. And we keep track of this information. That's why we have this type of line, because basically if you see for July, okay, the user did some change at the forecast for this particular period, for this particular lag zero forecast. And actually it's improved. So instead of being minus 92,000, we are just minus 5,000 compared to the origin, to the real demand data. And you can see that the value added actually is positive, because here it's in green, which means that the change was positive in regards to this particular data. But if you go to the next one, you'll see that it's not always the case. Here we have the case where basically the user changed the data, but not appropriately. And we have the result is that basically we have degraded the forecast, and this is not what we hope to achieve. So this is really how we highlight the FVA, the forecast value added value, and you can access this data directly in the tool. You just need to, every time the tool archives the previous forecast, you get access to this data, and they are computed on the fly. Okay. So that's it for the latest and fourth dimension. So if you think this is interesting for you, you have the options to open a free account. So this is you can get a free account in 5 seconds, as I explained earlier, and you'll see the demo data set that I have demonstrated. So you'll be able to play with several forecasts and see how you can compute this information. And also what we did recently for our customer, in order to help them actually start with SKU Science if they're interested, we created this SKU Science success pack. Let me share it full screen. So basically, we help you, and we help you analyze the current forecasting process that you have set up in your organization, and we help you define your needs according to the framework that Nicolas just described, and align those needs with this framework. Then we help you define the role and responsibility of each member in your team for this new demand forecasting process. We of course help you set up your account and upload all your data properly to make sure that you can you can start working on it without any problem. We help you create the first forecast in order to start applying the best practices. and add some value on the forecast baseline that the tool will compute for you. And last but not least, you can actually get our support during the second forecast cycle in order to make sure that this is actually appropriate, and you can improve your forecast one cycle to the next one. So that's it for the quick demo and the presentation. I know that it's condensed, but we just allocated 45 minutes to this webinar. So probably, I don't know if there is any question. I don't know, Thomas, if you were able to.
Maybe, Stephane, I was reading some questions, so maybe you can, I will answer a first one.
Yes, there's one for you, I think, Nicolas, the first one, actually.
I think in any case, Stephane, while I answered this one, you might want to go through the rest, because I think it might be interesting for the audience as well. So we received a question from Usman asking, once we have a model, how do we choose the right horizon? And then what would be the best way to forecast over the very long term, over 5 years? The first question, I think it's not a question of once we have a model, what's the right horizon? The question should be the other way around. First, you have to assess what's the model, what's the horizon you need, and then we can discuss, okay, what model will basically suit this horizon. If you want something short term, we can go for a specific range of model. If you want something long term, we might need to use another range of model. Now the question of, okay, how do we forecast demand over the next 5 years? That's a very long-term forecast. Usually if you do such a thing, you don't want to do so much demand forecasting. Instead, you might want to do scenario planning. So you need some kind of a tool that you can easily tweak. You can easily try different assumptions about, I don't know, trend seasonality, product introduction and stuff like that. So you can play with scenarios rather just than to get a forecast from the system. So I think it's more like a scenario editing context. I'm just gonna go through the other question. Yeah, we received another question from Anna on how to deal with very abnormal events like the COVID-19 or any other outlier. So we didn't discuss outliers. Nevertheless, outliers, supply chains are full of outliers, and you really need to take care of outliers before doing a good forecast. So you have different ways to deal with it, but what's for sure is that you need to do something about it. I'm actually quite concerned for all the demand planners that will need to forecast March 2021, because most of the statistical tools in the market will just basically show the same seasonality of 2020 and 2021. In SKU Science, what we created is the ability for you to basically flag outliers, and we even did it just for COVID-19. We, as Stephane is showing you, we created a tool that will basically allow you to get rid of all this period and replace it by what would have been the value if not for the COVID. So this should really take care of the COVID. In case of other outlier, you can either flag the value or period as an outlier, or you can basically manually edit it. We just received another question, which I think it's very nice.
Maybe I can show in the tool what happens. So basically, I'm sharing the interface, and this is where you decide to activate this option. And what we do actually, so my data set stop at the end of 2019, but if I add some data for 2020, it would be the same. So basically, you put your starting date like March 2020, the number of period where you want the tool to replace the demand that you add for this period with some forecast data. And basically what it does, I will show you here. So if you decide to activate this option, this information that for example, that is part of this, that is the one that you want to replace, you will see a new data here that will replace this one for the model. So we'll keep the real one, but the tool will use a different data to run the forecast model, and will replace this data with this new data that has been computed when we compute the forecast. So this field here will be automatically populated by the platform, okay, according to the number of period that you set in the system, and automatically the tool will use this data for the forecast. Okay. I believe it replies to the question.
Yeah, I will move then to the question from Manian, which I think is very interesting. How do we determine which method is better? So some of you might read on internet, okay, in this kind of pattern, you should use this kind of model. If your demand behaves like this, you should go for this specific kind of model. And I quite often receive the question, okay, Nicolas, but what's the best method? What's the best model? If I have this, what should I do? Actually, there is no black or white answer to this single model will basically be the best overall. So what I always advise to everyone is to use what I would call a data science approach. Try out different things and choose the one that works the best. As said, you should really take a step back and ask yourself the question, why am I forecasting? What's the right horizon? What's the right set of metric? Then you try out different model and you just select the one that's working the best based on the horizon you want and the metric you want. And at the core of SKU Science, this is what's happening. We try out a wide range of models and we keep automatically for you the model that worked the best in the past, making sure that we optimize both the right horizon and the right set of metric. I think, Stephane, maybe people will be interested to hear some of the questions from Dario and Thierry that Thomas reply privately. Maybe we should just quickly go through this question. I think it might interest the rest of the audience.
Yes,
I didn't reply privately. Everybody should be able to read the answer, but anyway, Stephane can elaborate if you want.
I can show you how it works basically. So if you actually you have the ability to, so what is the question first? So if you change data at an aggregate level, I mean, how does it downstream to the lowest level? So I just shown it for one type of aggregation, which is part number, but you could decide, you know, to select family and channel. Okay, so it's up to you really to decide the way you will organize your field. Okay, and you'll see, by the way, on the right that I have 59 elements out of this aggregation. So, and if I change any data here, okay, all the lower level forecasts that are composing this family 29 and channel 8 will actually, the way I change this data will be downstream according to the weight of each lower level forecast. So we have some calculation, and every weight is complete for each period, and we automatically downstream the right amount of percent of this particular data that will be changed to the right level.
What's important here is really to understand that why we did it that way is really to help planners to quickly edit the forecast. So if you have some information that says, oh, we're going to do some marketing event for this specific channel for this specific type of product, you can quickly go in this tool and select, okay, I want for all the product within this specific segment and for this specific channel to increase or reduce the demand for a specific month. That would really allow you, if you have an interesting piece of information, to go in the tool and edit it.
Yeah, or if it's a specific geography that you want to, okay, you want to set, you say, okay, this geography will be impacted. I will have only 70% of this business because actually there's a big problem. So I just type 70%, automatically, you know, I've reduced all the numbers by 30%. And you just have one data to change. And if you have, let's say, 1,000 forecast under this one, I mean, 1,000 forecast has been updated directly.
We received another question from Manian again. I'm going to try to explain the question in simple terms. He's asking, what's the best approach? Should we forecast everything at a very granular level and then aggregate it to the top? Or should we start from a forecast from the top and go to the lowest level? Again, before you answer this question, you really need to ask yourself the question, what am I interested into? Are you interested to have the forecast right at the global level, or do you want to have a very granular level, right? Once you know this, and once you set the right set of metrics, you'll be able to try out different techniques and see which one works best. Now, in this specific case, usually I would advise people, it doesn't work in every case, but I would say it works in, let's say, 80% of cases, that if you need a forecast to be made at a store product level, it might just be better to do the forecast at product store level. If you need to have a really good forecast at, I don't know, monthly aggregation at country level, it might just be easier and it works better just to do the forecast at this level right away rather than to play it through other level, okay? Nevertheless, it's not a black or white approach. In some other case, it might work differently, but overall, that's what I would advise.
But it's true that I haven't shown that not only we compute the forecast, I mean, at the lowest level. Okay, you see here it's automatically selected by the tool when you launch the computation, but you can also have it computed at another level. Okay, here, so we can compute the forecast at this aggregated level that I have decided. Okay, and automatically the new forecast computed at this level will be downstream. And the way you can see it, so normally it's automatically downstream, but you can see the difference because I have the option to show you that I have another forecast. So this one is coming from the aggregated level, okay? And I can also show you the one that is actually which is the other one. So you can compare various versions and do your own analysis based on this type of forecast, and you can compute them at various levels. You see, it's not the same.
Someone else asked the question, but can we add some external information? Generally speaking, in many cases, yeah, to address the question, and I want to tackle the question from another point of view. The specific question was for customer orders, but more generally, you could think, okay, but if I have marketing budget, if I have pricing information, could we use this to do the forecast? Statistical models usually do not perform well with extra information. Nevertheless, what we've seen over the last years is that machine learning does a really great job of combining pricing information, marketing information, and past sales trend, and combining this into a final forecast. If you're interested into such a thing, if you have the data set, if you have the data with all historical pricing, future pricing, marketing event, and so on, we can also work through SKU Science in creating a dedicated model that would basically exactly fit your own data set.
There's a question from Violette, I think.
Yeah, Vivek, so that's a very interesting question. So when you deal with inventory optimization, you basically want to look at forecast error, right? And basically, the higher the forecast error, the more safety stock you want to have for a specific product. Now, what is actually really difficult in the inventory, in the science of inventory optimization, and I'm going through this in the second book I published this year, is that it's extremely difficult to assess the spread of the forecast error. What we usually see with the statistical model is that we see a spread of possible forecast error around the forecast. One of the limits of this is that it's basically assuming that you're as likely to go above and under it, which is the usual assumption done by everyone. There is another assumption that once you start to work, and this is kind of a technical mathematical question, but if you work with inventory, it's also assuming that the forecast error is independent from one period to the other, which in practice is wrong. So if you want to do inventory optimization, we could definitely add this spread of error, but again, it would just rely on this, as you said, normal assumption. Now, if you want to be extremely good at inventory optimization, you want to start to go with custom distribution. And in order to have this, you really need to use some extremely advanced machine learning model. And definitely these kind of model do not come out of the but nevertheless, I'm very happy, Violette, to discuss the subject with you and see how we can include what you need in these forecasts.
Okay, I think we don't have any more questions. And we are reaching the time limit that we assigned to this webinar. So if you have an additional question, you should do it now because we're about to close. No more question. Okay.
Feel free to reach to us if you have any more questions. I'm very happy to rediscuss some points.
Thank you all, and wish you a good holiday season. And thank you again for attending this webinar. Thank you, Nicolas. Thank you, Thomas.
Thank you.
Thank you. Bye.